The only really common issue I saw when grading the written assignment this week, so that's written assignment 9, is the question about algebraic multiplicity. So a lot of you guys found the correct characteristic polynomial using the determinant, which is which was not a small task, so thank you for doing such a good job on that. So your polynomial looks something like this, and then you set this equal to 0 to find the zeros of the characteristic polynomial. Now when you set each factor equal to 0, notice that really with the lambda squared there, we could write that as negative lambda times lambda minus 3. I mean, so if we really broke this down to linear factors, lambda equals 0 would be a solution twice. And then we would get lambda equals 3 as a solution once. So in this problem, 0 is an eigenvalue with multiplicity 2 because it's a 0 of the polynomial twice. 3 is a 0 of the characteristic polynomial with multiplicity 1. I'm just going to abbreviate multiplicity 1 because it's a 0 of that polynomial just one time. There's only one factor that corresponds to that 0. There are 2 linear factors that correspond to this solution. The shortcut to finding algebraic multiplicity is just look at the power of the factor that gave you that particular 0. Since we got lambda equals 0 as a solution from this factor here, and it's to the second power, then you could jump right to the multiplicity 2 here. And since we got lambda equals 3 as a solution from this factor, which has the first power on it, then lambda equals 3 is a 0 of multiplicity 1. Just another quick example to drive this point home. So if you had a characteristic polynomial, say lambda minus 4 cubed, lambda plus 1 squared, so if you set that equal to 0, the eigenvalues are lambda equals 4 and lambda equals negative 1 by setting each of those factors equal to 0. Lambda equals 4 is raised to the third power. It has algebraic multiplicity, which I should, since that's different from the geometric multiplicity, that has algebraic multiplicity 3. And this factor has the second power, so lambda equals negative 1 has algebraic multiplicity 2. The geometric multiplicity is equal to the dimension of the eigenspace for a particular eigenvalue. So it's the number of vectors in your basis for the eigenspace. But you guys solved that correctly more often. It was the algebraic multiplicity that was an issue.